I welcome you all to this webinar on eliminating the test fail fix tax on your data center budget. In this webinar, we'll discover how Ansys Solutions enable infrastructure leads to predict system bottlenecks and thermal inefficiencies months before the first server rack is commissioned. Today we have with us Mr. Shashikant, who's the National Technical Manager at Softcell Technologies. He is our speaker. Mr. Shashikant is a seasoned multiphysics simulation expert with over 12 years of experience in CAD, 3D modeling, FEA, and CFD. Mr. Shashikant will take you through a quick overview of Softcell Technologies and then start with the webinar. Over to you, Mr. Shashi. Thank you.
Okay, thank you so much, Tanvi. Okay. Hello, everyone. I hope all are very well. So, my name is Shashikant, and I am National Technical Manager in Softcell. So today we are here to see solutions which can help to develop a better and better efficient data center. So we will share with you some knowledge and some experience whatever we have in past. So before going ahead, let me introduce about Softcell. We all are from Softcell. Softcell is a tier one partner of Ansys company. We are very well-known company in the India. And wait 1 second. Let me make forward. Why it is not going? 1 second. Let me reshare once again. Yes. Yes. So the agenda for today webinar will be, we will just give an introduction of Softcell, and I will showcase you some Ansys solutions and how simulations is very useful for the development of data center. And I will showcase you some pain points, whatever I observed in my past experience, and how these solutions can help you to do to simulate electrical simulation, thermal simulation, and stress simulation, and how we can see how we can maintain and make more efficient power management for the data center. And at the last, we will showcase you sustainability using Ansys solution. So Softcell is a 30-year-old company, you can see here, and we are in the team more than 50 plus team member. And last year revenue was 1,024 CR, and our office is available in six major cities of the India. And we have more than 3,000 customers with us. We are partner for PTC and Ansys and Microsoft HoloLens and Sigmatrix. For PTC, we are supporting on CAD, PLM, ALM, SLM solutions, and AR and IoT. In Ansys, we are supporting for mechanical, fluid, thermal, material, redesign, electronics, electromagnetic, and FPC and cloud-based simulations. Like some solutions which can help you to validate your product virtually. And Sigmatrix, we are supporting for geometric dimensioning and photon CT&T and analysis. We are also in the AR, VR and solutions. We mainly do technical support, license support, and engineering services. So these all are the major cities in the India where the Softcell is available. Okay, so a trend, whatever is going in the worldwide in the market. So everyone want to see the failures before going for the production, going for the implementation. They want to identify solutions before any losses. So AI-driven infrastructure is main requirement, and we need to have also energy efficient and sustainability structures, and we need to have a reliability and safety criteria. So these major things is required for overall market, whatever is going under the development. So in the terms of the data center, we need to leverage electronics and room design for the operations and maintenance. and management. And for the grid and stability, we need to utilize ensuring power stability and utilizing environmental awareness. And in the terms of the thermal management, we need to see engineering thermal reliability from chip to facility. For in the terms of the computer performance effectiveness, we need to utilize maximizing performance and capability with design flexibility. For the power generation, we need to enabling power generation and insight management. So major, if you see in left side column, we have a major challenges for the data center. In right side, you will see these are the solutions which are available with the Ansys synopsis. So we have a AI adopted solutions which can give you solution very fast and very impact way. And we can also help you to reduce innovation cycle and accelerate time to market. And we utilizing these solutions, we can save time and cost, minimizing prototype costing, and move directly to the production. We can also utilize leverage virtual performance prediction to enhance design. So we are available in a wide range. So we can do some related to the fluids. We are in also some thermal. We are in mechanical. We are in software applications also, OS and middle layer and applications, and electricals and reliability and PCB and power supply efficiency and optics and silicon. So we have a solution from silicon to system. It is a multi-phase solutions which can be coupled for almost all type of challenges, all type of pain points. For the data center, first thing is coming in the electronics and chip room, and the second is infrastructure for the cooling system, and third for the power generation and distribution, and fourth for the environmental sustainability design. So every data center is having racks and some modules, electric modules, and bus duct and HVAC system also there. Wiring is also there. They're available cooling machinery, AHU, centralized AC, multiple things are there. And for make it more sustainable, we need to have another component also. So there are many things which need to utilize for the data center. So what we can do, we can cover these all product line or pain points to simulate to see virtually when we are going to be implement. So this type of response will generate using these complete infrastructure and complete information of the component level. So system level, we can do simulation system level, subsystem level, and we can do also validation, having some previous data of the physical response. So majorly, I will give you a very easy way to understand how we can support and how which type of solution we can resolve. So every data center is having racks. On racks we are having electronics modules, and electronics modules is having fans, PCB, and multiple things are there, which is running and with the power consuming. So the fans and PCB is having specific type of vibrations. They have a high heat generation. So because of high heat generation, we can see thermal stress is going to be generated on the racks through the modules, and this heat also will be delivered in surrounding air. So it will generate also hot spot near about the region. And once it is going to be distributed complete atmosphere of the we can say inside of the data center, it create a multiple problems. Okay, so we need to maintain multiple racks. We need to maximize multiple racks in the terms of the efficiency. So what we can do, we need to have a proper HVAC system, proper thermal management, proper structure management. So once we have these all things, so we can create a best efficient data center. So we can cover electromagnetic type of simulation, we can cover thermal simulation, we can cover structure simulation, we can cover EMC, EMI simulation, we can cover also environmental simulation. So if you see, like, majorly every structure, every data center is having multiple types of the simulation. So major simulation is required, electronic simulation and thermal simulation and structure simulation. So this is a complete flow path for the electrical integrity. So let's suppose you are having some PCB boards and some modules that you want to simulate when it is running. So how much heat will generate, and you want to simulate signal integrity, you want to simulate power integrity, you want to see connector and cable response, you want to see electro optics system simulation, and you want to see radiation, EMI radiation, conducted EMI radiation. So these all things you want to simulate. So these all can be captured using Ansys Solutions. Just we need to have a Java file, we need to have a step file that we can import inside the solution. Then you just apply boundary conditions, whatever is required. So you can see signal integrity, you can see power integrity, and because of the PCB running, which type of thermal stress is generating, how much heat is dissipating surround area. So it may be single PCB, it may be complete package, complete module. So that also can be simulated, and using multiple modules. Once we assemble these modules, and it convert as a server and racks. And once you have a server and racks, it convert as a data center. So these all electronic simulations you can do virtually before going physical, we can say construction or implementation. Let's suppose what is the simulation? Just I give you the easy and the honest answer. Let's suppose you are not utilizing any virtual simulation. You are going to implement directly. Then you will have so many challenges. So what we do normally, let's suppose to get a required or efficient data center, you will do 10 or 15 iterations, physical iterations and physical implementation process. So what we are saying always, don't do 15 iterations physically, do 12 or 30, 14 iterations virtually. Once you get satisfied with virtual process, then directly go for the implementation. So doing multiple iteration virtually, you can find out hotspot, you can find out power integrity problem, you can find out signal integrity problem, you can find out thermal stresses problem virtually. Then you can solve also virtually. Once you got improved structure, improved design, then you can go for the implementation. Okay, so whatever I said in signal integrity, because of the flow of electricity and current and voltage, whatever we have inside the PCB, so it generates something heat. So how we can maintain, how we can minimize the temperature, how we can resolve the hotspot. So we normally use two types of the process. One is a natural convection, and second is a forced convection. Natural means because of the surrounding air. Forced means we are placing some fans, we are placing some heating, we are placing liquid cooling channels, we are placing liquid plates. So we can apply advanced type of cooling system. So let's suppose you have some specific PCB or something server, or you want to find out, I want to maintain 35 degrees Celsius or 30 degrees Celsius, a uniform temperature. I don't want to go beyond of the 40 degrees Celsius. So what you can do, if you go with physical process, you will implement multiple iterations. You need to invest money to purchase hardware, to invest proper time to see response of your iterations. What you can do, you can design multiple 3D model using multiple type of iterations. Once you done your iteration, you can import these iterations inside the Ansys Solutions. Okay, once you get integrated, then you can see which design iteration is best for your requirement. So what we have also OptiSlang AI based solution, which can track your all results within a few minutes, within a few seconds also, and compile which solution is good, which iteration is good for you. So in OptiSlang we have a multiple Python based we can say sensitivity analysis, we can say optimization analysis, which can help you to check very fast which design or which concept is good as per the application. And let's suppose you want to simulate complete data center. You want to consider racks. You want to consider thermal tubes. You want to consider electrical wiring. You want to consider HVAC system, complete thing at the development stage. So what we have a thermal desktop. You can see in right side bottom the red and blue points. This is something 1D based solution. 1D means just you have a defined library of the racks and the HVAC system and all these things. Just drag and drop. You can see response of the complete data center structure or architecture. How it will behave. It is something we can say development stage. Once you get synchronized, how much racks should be required and can be there, which type of cooling we need to have, which type of structure racks we need to provide there. So you can you can finalize very easily using thermal desktop. It is something 1D based on simulation. So it can be done very fast within 20 minutes or 30 minutes. If you have a 5,000 meters per area, that can be also simulated very easily. So first we discuss all the electrical, and then because of electrical we are having some thermal responses, and because of the thermal responses we will see thermal stresses on the component, on the PCB, on the structure things. So for the structure we can simulate for a chip level, package level, board level. We can simulate stress analysis, we can simulate warpage analysis, we can do vibration analysis, we can do thermal cyclic analysis, solder reliability simulation we can do drop and shock simulations. And about the rack, while these models are running, we have so much vibrations. Sometimes because of resonance, we will feel something. The failures are coming there, so that can be also trapped before the implementation we can do on a virtual simulation. And electrothermal we can also do. So we have a big data centers. We want to do simulation also in the terms of the seismic analysis, wind analysis, or we need to see response on the cable and tram and foundation. So these also can be captured in the structure integrity simulation. So there's no limit of the size in the Ansys. Whatever you have maybe Revit. You are utilizing Revit. You are utilizing any other solutions. The 3D modeling file can be imported very easily. Once you get import 3D modeling file, then you need to define boundary condition and all these things as per the application. Once you had done, then you can see response of the complete system, complete architecture, whatever you have. Now about the power management. Okay, so power management is a big pain point for the data center. Data center is always consuming power in a wide range. Okay, so for the power distribution, we have a cables, we have bus bars, we have a magnetics, we have generator, we have a relay, switch gears, we have a power electronics, we are having thermal management. So these all things we are managing inside the data center, and these all things are consuming power very high level. So what we can do, you can do these all cable design in a different way. You can generate a different architecture, different flow path for the cables and bus bar. And you can see because of these different architecture and profile, which one is consuming less power. Okay, just I will give you one example. Let's suppose you have a specific reason, multiple racks. Let's suppose you have a 20 racks. Okay, so sometime shutdown is there because of some problem. Electricity is not there. So you are running some generator, and you want to find out how much generator is required to maintain the temperature of the data center. So what we can do, let's suppose you are having 3 HVAC systems to make cool complete data center. What you can do, you can identify really three is required, or we can do using 2. Let's suppose you did a simulation, you got two is enough to maintain the temperature. So what I'm saying, before the simulation, before the virtual analysis, you are running three HVAC system, and third HVAC system is running extra. This is not required. So how you can find out this before the implementation? So you need to have a similar type of solutions which can help you to do these type of solutions very easily. So you can generate multiple type of the iterations. Let's suppose you want to maintain we can say expect speed very less, CFM is very less, or you want to increase CFM in different shutdown conditions. So what you can do, you can create a Python code, or you can make a multiple Python mapping, which can maintain cooling for the data center for overall year. So you can put some, let's suppose shutdown is happening for two hours. So because of integration of the machine as per the CFD simulation, a specific actual system will start, okay, to maintain temperature. Let's suppose a shutdown is going more than 2 hours, then automatically other component will get a start. So these type of iterations you can do also in the Ansys solution, which can help you to reduce the power requirement for the data center. This is an example. Okay, so sustainability, we have a multiple component required for the data center. So we want to see also which can help for the clean environment, and which can help for the energy solutions, and material circularity and manufacturing and optional efficiency. So we have some solutions which can tell you how much type of PCB will be there, and which type of heat will be dissipated in the atmosphere, and how it is deflecting to the atmosphere. So which type of implementation need to required for the clean environment and for the energy solutions. That also we can do easily using an Ansys solution. So if you see, these some PCBs are there. You can see there, red means high temperature is there, blue means less temperature. And here you can see in PCB we have heat sink, we have some fans. There's available force convection. So as I explained earlier, so this is a complete data center operation. So sustainability and power system and HVAC cooling system, mechanical reliability, and acoustic noise reduction. So in the power, we have understood about the cable and bus power and data center power distribution, how we can utilize and the solutions to make more efficient, to reduce the power consumption. And we need to virtually before going implementation, always we try to find out hotspot and the heat pipe optimization, design optimization, and we need to see the flow level thermal analysis, how it is affecting, and where we need to place duct inlets. Okay, we want to optimize HVAC system for the industrial application. We need to optimize data center cooling process. We need to see, we need to utilize digital twin for the thermal issue. And in the terms of the mechanical, we need to utilize, we need to see vibrations failures. We want to see rack structure failures. And once these all things are happening, so majorly we have two types of the acoustic. One is the aeroacoustic, and one is the vibroacoustic. Vibro means something machine is running, because of vibrations, we have some specific dB. So for the data center implementation and all these things, we have some regulations, national and international regulations. The sound noise decibel noise should not be beyond specific 40 or 60 dB. So we need to maintain these all these things. So using the Ansys solutions, you can find out, you can see virtually if something vibration is happening because of vibration, which type of dB and how much dB will generate. If you want to see in some numeric words, in numbers in a text, then you can see directly. But let's suppose you want to feel, you want to hear in a real word, in a mobile phone, in a speaker. So we have a Ansys sound also. Once you get coupled with the Ansys sound, then you can feel in a real word. Okay. So in the aeroacoustic, some duct we are having. In duct we are air is getting flow. So because of air, we have some specific high pressure drops. Because of the pressure drop, we can feel some noises because of the air flow. So that type of things we can also capture using Ansys solutions. And sometime PCB we have a electromagnetic field, so that type of things we can also see because of this all electromagnetic behavior is happening, which type of noise can be generated. So now this I created a specific presentation as required for the data center, and these all are the case study which can help you to understand about the how Ansys Solutions can help you to resolve all challenges and pain points before going implementation in real world of data center. So this is one case we did done for our customer. So they are facing some problems in the terms of the footprint of the wastage and footprint of the data environment effects due to the this infrastructure. So what we can see once we are simulating the simulation, we can see because of the this all process which type of outcomes can become. So if we are having some carbon generation, if we are having some heat generation because of these all process, whatever happening in data center. So how we can resolve, how we can make our data center more sustainable, or we can say more clean environmental structure, or we can say data center in terms of the more efficient, more energy efficient. So what we can do, once you done the all virtual solution, you will get some output how these things is affecting to the environment. So we can resolve all problems using a specific type of the equipment, a specific type of the that structure placement for the data center. Now for the cable and bus bar. So customer was facing some problem for the cable sizing and distribution. They are placing some bus bars and cable, and bus bar is cable. They having very complex architecture, or we can say flow path. So we need to maintain properly. Short circuits should not be there, or losses should not be there. So we need to identify size of the bus bar or cable to reduce the loss in the power distribution and optimize trade-off between cost and efficiency. So if we are using required size of the bus bar and cable, then it is fine. We are using heavier size of the cable, so it is asking for more money. So we using virtual simulation, you can really identify which type of size of the bus bar of cable is required for the proper power distribution. You can maintain also some factor of safety in the terms of the power transfer. So we can also maintain that. But if we are using very higher size for the cable and the tray and all these things, then this is a tax on your data center, extra money on data center, and reduce unwanted coupling between cables. So we are having multiple cables, they are having coupling between cables also. So that also we can find out the failures and all these things also. For this solution, we can utilize Ansys electronic solutions, which can help you to identify these all pain points and generate proper architecture. We can say flow path for the cables and bus bar. So it can help you to understand losses and heat issue. It can help you to identify fault conditions, and it can help you to identify a load balancing and power quality, and make your system more effective in the system level. Now, this is one example we have done for a company. You can see this is a 3D model at top. This is 3D model for the data center. It is in the Rabbit file format. .rvt is very easily importing the Ansys software. So once you get import the 3D model, and you can define the we can say application based boundary condition of complete system. Whatever you have PCB, you have some specific fan, you have some heat sink, so you can give a heat sink property. If you have a specific fan, you can give a span RPM. You can define all conditions as per the application. So the customer was facing some problems in the terms of the hotspot, and they want to ensure efficient compact data center, and they want to maintain a moisture level inside the data center. Sometimes we are having higher moisture level. So because of the higher moisture level, PCB and all electronics components will get affected. So some spark is there, some problems will be always there. So we need to maintain also moisture level. And development for the action for the cooling system failure scenario. Scenario means sometimes shutdown is there for long time. So you need to have some scenario, you need to have some plan while shutdown is going for a long time. Let's suppose you have 100 HVAC systems in your complete data center. Maybe first HVAC is not running, second HVAC is not running sometime. These are the machines. Machines can be stopped any time. So what we need to have a proper plan and proper synchronization with the all machine and backup also. So that if you do physically, it is impossible. If you do virtually, you can integrate thousands of iterations, thousands of ideas in the terms of this scenario for this shutdown and temperature maintaining. Okay. So this all can be implemented very easily using virtual simulation. So they requested some type of results. They said, let's suppose we have a 20 HVAC system is there. Maybe a third HVAC system is getting shut down. Maybe is getting off automatically because of some failures. Okay, and how we can maintain these things. So using this integration, Ansys can tell you which HVAC system need to be run very faster. We need to increase the energy. That also we can do. Okay, so which type of backup is required? That also can be performed very easily. So using these all iterations and all these things, we can make more energy efficient operation for the data center cooling equipments and enable building compact data center excellent reliability and diversing failure management system and emergency mitigation. So emergency means you have a multiple system, multiple things. Anyone can just stop anytime. These are the machines. So we need to have some specific plan in our data center operating process. So that process can be implemented, can be designed using Ansys Solutions very easy. This is also one example for the data center cooling. You will see we have a multiple racks. On the multiple racks, we have at top ceiling level cooling. And the right side, you will see right at top, you can see there is available 2 racks. So first image, you will see red color is there. Complete rack is under high temperature. Red means high temperature. Once the proper cooling process is there, proper management is there, thermal management is there, you can see in right side, we have a very less high temperature zone. Okay. So red means high temperature and green means blue means low temperature, and green and red is between temperature. So before the proper thermal management process and the ideas and implementation for the cooling, you can see rack is getting very high temperature. So because of high temperature, so many failures can be occur there. And once you are having proper thermal management, all these things, you will see temperature is getting reduced. Okay. So using the virtual simulation, you can also see when the rack is running for the 20 hours, 30 hours, 40 hours, maybe 1,000 hours. So which type of temperature behaviors will generate, or which type of mechanical behavior will generate, you can predict virtually. Let's suppose you are having some challenges virtually, you can resolve virtually. Once get resolved, then you can go for the implementation. So there is no limit for the size also. You have seen at bottom 50,000 square feet data center is there also. So it can be solved a very efficient way. We can see multiple type of things. If you have sometime AHU is there, sometimes we have a chillers also. So that also can be implemented. So we can do silicon to system level simulation. As I told you, for the complete data center, we can say at development phase, how we can optimize the how much racks can be there, and how we can increase the efficiency of the data center. So we have a thermal desktop. We can couple with the office line. So you can give some input. You have a maybe 1,000 racks, maybe 5,000 racks. You have a specific module between racks. You are having this much space and all these things. You can do all these things, and using 1D solution, software can tell you which type of efficiency can be generated to the data center, and how the thermal behavior will be there, how the structural behavior will be there. And you can see this solution has been executed within 15 seconds. So the automation is very easy for the virtual solution also. And Ansys, we have an office line and AI integration. AI means you can integrate your ideas and all these things. It can simulate very fast and can give you results in the terms of the which iteration, which idea will be better for your application. This is one for component based simulation. Let's suppose you have an HVAC, and HVAC you have this similar type of the duct. We have a some fluid air is going on. The profile of the HVAC is not proper. We will see a certain pressure drop. Certain pressure drop, we will feel high noise, high dB, decibel. Okay, so we need to have also proper type of the the HVAC profile, where pressure loss should be less and very smooth airflow should be there. So if you do it in trial, it requires so much money, so much time. So you will see at top right top the large recirculation is happening because of the airflow. We can see also pressure drop will be there, and the right side bottom you'll see we did some changes in the HVAC profile and the duct profile. Then this recirculation is not happening. So these things is very easy to give a proper cooling for data center. Once all things happening inside the data center because of the thermal and all this behavior, some loading will be transferred for the racks. You can see because of the vibration and because of the multiple loadings, we have seen. You will see that the red mark is there. So there we have a high stress. High stress means the rack can be failure from this location. We need to see why it is happening. Once you done any virtual R&D or virtual research, then you can predict virtually, and you can implement multiple types of the dampers, multiple types of the space between the modules, or multiple types of the cooling management to resolve these type of challenges. Virtually process is very easy, but let's suppose you are going to physically, you need to ask to your electrical vendor. They will come again and they will they will see, they will implement this challenge changes within 7 to 8 days, and this also disturb surround machines and surrounding racks also. So we can finalize the critical component under the seismic, under the wind load, or maybe under the high temperature, thermomechanical, electromechanical. All these things we can capture very easily. And as earlier I mentioned about the acoustic. So if some fan is running there, you will see there fan is running there. We have a different type of fan profile, blade profile. So how much CFM it will generate, and how much dB will generate. So this is not only for the aeroacoustic. It can be for the hydroacoustic. It can be for the vibroacoustic. Whatever equipments you are having, some vibration loading generation, you can see the response of the equipments. It is always majorly in two parts also. One we can say far field or near system, inside system. Far field means, let's suppose any HVAC system is running far from my location at 500 meters. So after 500 meters, how much noise is there? It called as a far field. Let's suppose you are available close to the machine. It called as a near system or inside system. So far field, you want to feel how much noise will be there, that also can be captured. So this is a summary. But whatever we can what we can utilize Ansys Solutions to resolve the challenges, to solve the challenges using virtual simulation. So first, as I explained, first we can handle we can resolve the hotspot and poor cooling process. It mainly happen because of the non-uniform airflow and rack overheating. And we have a solutions, special solutions which can help you to eliminate hotspot and improve cooling efficiency. And second, for the high energy consumptions, power uses energy, we have here. So in inefficient HVAC and cooling layout, sometimes we have. So because of that, it is happening. So we can save energy up to 20 and 30% in the terms of the making a proper cooling and all these things. So just for example, we have let's suppose we have a 100 meter HVAC profile, but 100 meter is very lengthy. Let's suppose I want to see. Let's suppose we are creating subdivisions of the HVAC. It comes maybe 90 meters. So using 90 meter cooling can be efficient or not. So these type of things we can do very easily. And the rack level thermal management, that also we can capture using iSpec. We have iSpec. So electronics heating is there. So because of the electronics heating, we want to do reliability simulation and thermal management solution, that also we can do. And containment strategy and design simulation, as we can say, to virtually simulate how the cooling can be more efficient. Sometimes we have a data center as a liquid cooling design base, that also we can simulate, and we can also capture airflow, obstruction, and recirculation. We have also a regulation for the data center for the fire safety. We need to place proper fire safety equipment, that also we can simulate using virtual simulation. The fire safety structure, the architecture and the system is good enough or not. And for the structural integrity, we can do vibration noise, we can do power equipment heating, we can do also cable thermal management, we can do also, and cooling failure scenario we can simulate also. Humidity simulations we can do also. Data center layout optimization using OptiSlang, as I told you, how much racks can be increased to maintaining proper power consumption. Okay. And we have some compliance in the terms of the lead and for the building compliance. Maybe you have all have seen in the market, some buildings are having LEED certification. LEED means they are not creating waste for the atmosphere. So whatever we are developing, we are creating, we need to have a proper machine, a proper dissolving process. It means there should not be any effect to the atmosphere. And as data centers, as I said, limited space, high density. Let's suppose we are having very limited space. You want to see, you want to utilize high density racks, and you want to simulate how much power can be optimized. So these all iterations can be happen very easily. So these are some takeaway from this session. We have a compressive solutions in the terms of the electromagnetic, fluids and thermal and structure and optics also. Optics means sometimes we have a racks with the glasses. Glasses means the glasses is available there, and because of the modules and PCB heating, the glass is getting faded. Faded means the visibility will be less. So these type of solution also we can do. If you want to see visibility simulation, you can do also using Ansys optics. And we are in also advanced physics support, two-phase cooling and immersion cooling. We are also in the multiplex electrothermal, thermal mechanical reliability, and we are leading industry for the accurate simulation in terms of the chip and package level, server level, rack level, cluster level, room level, and facility level. And we are also having digital twin. Digital twin means we can create a room model, reduce order model. It means we have some physical response available, so you can couple with the Ansys. So Ansys can simulate as per the physical inputs available. That also can be implemented with the AI of this line. So to identify the failures in a very beginning stage. So this is something very useful for specific type of pain points if you have. Okay, but we have a huge of solutions for huge of challenges. Really, honestly, virtual simulation is very helpful to identify the pain points and resolve these pain points before investing a lot of money, before making yourself in danger. Okay, so I will show you some software field, how the software is working. So you can understand very easily about these softwares. Okay. So let me share my screen. 1 second. Okay, so this is a Ansys interface you can see here. So what is beauty of Ansys? I love always Ansys Live. I'm using Ansys from last 14 years. I will introduce about myself. I did a bachelor's in mechanical. I did masters in design. I did a PhD in material science from CSIR and PL New Delhi, from where our IST tag is maintaining. And currently I'm doing masters in AIML through IIT Bangalore with the UK level 2 university. So I used multiple solutions in market, but I have seen only one solutions where the process and it's very user friendly software. So you will see all type of physics in a single window. There's no need to import, export for multiple softwares. Let's suppose you are having one rack. On rack you are having running some PCB and fan. Because of fans you are having some heat, and this heat will defect to the PCB, also to the structure of the rack. What you can do, you can just drag and drop. You can drag and drop the behavior of the fan for the structural analysis, and you can see because of the heat, this type of thermal stress will be there. You will see. Let me show you an example. Let's suppose I did a structural analysis here. Something we can say. Sorry, it's a thermal analysis. I want to utilize the output of this thermal as a structural analysis. That you can drag and drop. So you just think one thermal analysis has been done in this B system because of the PCB heating, and because of the PCB heating, how this will affect to the structure. So you can see I coupled with the structure analysis. So this is very easy to simulate all these things. Let's suppose you want to go with the fluid analysis, the drag and drop. You will see you are utilizing geometry for the structure for the CFD analysis. So coupling is very easy. There's no need to export from one system to import in another system. So why Ansys is overall more than 50 years old software, and we have multiple partners. We acquired multiple companies who are already in the expert in their field. So this easy process. Otherwise, if you go for another solution, they will not have something easy process like this. And we have also available free resources for the learning. Just you can go for the Google, you can type AIC Ansys. Let me show you if you want. Start AIC Ansys. We have this website. This collaboration done with the Ansys and NPTEL for Bharat Sarkar. You will see all courses are free there. You can see that. You will get a direct knowledge with the expert. So Ansys expert is there for the software explanation, and physics expert from the IIT and NITs, professors and scientists are there. They are teaching all the how the equation is happening. Let's suppose you will go for the fluid mechanism. Just click here. You will see go to course. If you go there, you will see the complete course will be there. You will see videos are there. They will teach you what is happening in the terms of the background. Okay. Let's suppose you want to see PPT also. You can see PPT is also there. Core knowledge. Okay. There's no filter, nothing. You will see all the steps are there, and you have also quiz, and even you can see the magic. We didn't do any login. Without login, also you can watch this complete tutorials. Okay. So a direct knowledge you can gain very easily, and we are also available here to support you. We love to support you. If you have some specific challenges, if you have some specific requirement, we always welcome with your challenges, whatever you have, you can discuss with us. And if you want to do any demo on specific product as per your requirement, we can also do. And so let's go ahead with the simulation, how we can do simulation. You will see the complete components are there, multiple pieces are there. We'll see fluent, electrical, and all these things are there. And let's suppose you want to define the material property. We have a library. So normally what we have, we can define this multiple type of property, plasticity, creep, life, all these things. So simulation means if you give a garbage to the system software, you will get an output as a garbage. So input is very important for the simulation. If you give a more accurate, then you will get an accurate result. What I'm saying, you will have a freedom to define your setup as much as accurate using Ansys Solution. You will have a multiple inputs to provide there. Okay. And let's suppose you want to utilize steel material, you will have it there. If let's suppose you want to go with library, you have a library here. You can also utilize from the library. Let's suppose you will say, I want to create your manual, customize, you can also create customize. And about the geometry, I will just tell you, we have a multiple option for the geometry. You will see here. Let me show you. So we have these options. You can see we can import step file, we can import photos file, we can import Revit file, we can import Parasol file. We have a multiple type of file format that can be imported very easily. More than 25 file format. .rbt, SketchUp file, you have maybe 3ds Max file, you have a Maya file. These all files can be easy to import. Once we have a file there, then you can see I place some racks in between. You can see these are the racks in between. I place three inlets, and these are the 3 outlets. And once you have this 3D model, that you can do math. Once you done the math, you will see you will go for the solution. So in solution, you will have an option for the defining. You want to do transient simulation. You want to do steady state simulation. You have multiple options here. So in transient means time dependent. Let's suppose you want to see after running of the extract 20 hours, how much temperature will be there. That type of results also you can get. Okay. So I did define the inlets and heat generation by the racks on all these things. Then you can see the response. You can see these racks are generating some specific heat. These are these heats, okay? And let's suppose you want to see the airflow from the inlet outlet. You can see the airflow, how the airflow is happening. So air is coming from the inlet, and this is going to be flow and evacuating heat from the racks. So let me go there back, and you will see blue is a very less temperature, 22 degrees Celsius, and higher temperature, 60 degrees Celsius. So you can see in between the heat is getting dissipated inside the data center. So it is evacuating heat and exhausting heat to the atmosphere. Maybe for the system. So this you can see here. So these type of things you can do very easily. Let me show you animation also, so then you can get understand very easily. This is you have a very big complete big 3D model, and you are having racks, and you are having modules, you are having ducts, you are having cables and all these things. You can import very easily. You can synchronize with the Ansys software very easily. So this is also, you can see step by step all options are available. So once you done geometry done. Once you done the math done. So if you follow this complete flow, then your simulation will be done automatically. Let me show you the flow, how the flow is happening. Just give me 1 second. Let me start from inlet, all inlets, and apply. Let me increase the density of the streamlines. And let's suppose in between you want to see because of this inlet one, which area is covering properly. Okay, that also you can check. Let me show you the flow, how the flow is happening, how the heat is dissipating, extracting from the racks. Okay, and let me go there. Let me click on this, and you will see the response. Let me make it stop. So, you can see the flow, how the flow is happening. So these are the flow path lines. Okay. Let's suppose you want to see the response of the on only one inlet. Let me do only one inlet and okay and say apply. Majorly the air should come cover to the racks properly to evacuate the heat. You will see here if we are having one inlet. Let's see about the if we have an inlet one and inlet three only and apply. So now you can see the majorly these two inlet are covering the heat dissipation from the racks. So we can change some angle for the inlet. So we can utilize only two inlets. We are applying three inlets. It means we are using high energy for the cooling the system. So you can do multiple iterations. We can identify how much optimized energy required for the cooling the system. So if you do physically, it need a lot of money, a lot of time. But suppose if you want to see the response in terms of the temperature, how much temperature is coming out for the outlet. Give me 1 second. Let me show you 1 second. Outlet 1. You can see 33. Let me do one thing. Across. So here we have a multiple option. We can change the all data, maybe text size and all these things. Whatever is needed as per the application, and we can also justify which type of controls you require. All these things is done. So you see here maximum temperature we have a 333 Kelvin, and minimum temperature we are having 295 Kelvin. So you can see the response here, how the response is happening. So you can see that some red or something we can say in terms of the less blue. Less blue means it is evacuating the heat. So these all capturing you can do very easily using the Ansys solution. Let me do one more thing to understand very fast. Let me go for the local fine. I want to see the response in the terms of the two with three. So approx 300 Kelvin temperature is there at now outlet. So these all things you can see how much inlets or how much HVAC system we are using, how much heat is dissipating from the racks. So this is Ansys Fluent. Let me go for some rapid simulation. This is the rack model. Rack model means we have some specific model here, and this is heat sink. On heat sink we have some plates. Just for example, I created for you, and I want to see the response of the. Let's suppose we have some specific heat to the model, and I want to see the response of the this IC. This heat sink, and we have a fluid based cooling here. So we can define the flow rate of the fluid, whatever we have. We can define the material for the heat sink and the tubes. Just click on the start. You will see the response is coming very fast. So this is the Ansys discovery. It is very fast and easy software which can simulate very easily, very fast simulation. If you have a big structure also, it can solve very fast. So rapid, we can see it is a rapid simulation. Let's suppose I want to see the response of the temperature. So we are having here, let's suppose we are having average temperature is 52 degrees Celsius. I want to see, let's suppose we are increasing the speed, or maybe we are increasing the decreasing the coolant temperature. So how the temperature is minimizing for the overall system. So you need to wait for a few seconds. It gives you response very easily. So you have a multiple options here. You can see velocity contours also for the flow, how the flow is happening. So you can see the coolant is coming from this location, and it is consuming the heat from the module. And it is going flow path from this property. It is going for last phase. Let me do one thing. I will show you some component and you can understand very easily. These all are the components. Let me hide this thing and let me make a path line. Then you can see how the flow is happening. Yes, now you can see. So the coolant is flowing from this side into it is going for outside this side. So these all things you can simulate very easily. You can capture all behavior, and you can see if you are changing the inputs, if you are changing the design, how the response is coming. You can see we did some changes. Initially, temperature was 52 degrees Celsius. Once we did some changes, the temperature, average temperature is going to be reduced. It is approx 23 degrees Celsius. So the virtual process is very easy, and using Ansys Discovery, it is very fast. So it is, we can say it is implementation. If you are doing some implementation, before implementation, try to utilize this rapid solution simulation to see failures virtually very easily. Okay, so for today it is done. If you have any question, you can put in the text box. I will give you answer. Let me open the 1 second. Let me stop sharing. 1 second. Let me go for the sharing once again. This here. Now, please put your question in the text box. Before going last, I will just showcase you last thing only. This is a complete portfolio of Ansys software, Ansys Solutions. We are having more than 52 solutions with Ansys. If anyone having questions, kindly text. Let me see if there's any text. Okay, I think we can wrap up the meeting. Okay. If you have any question, if you have any challenges with your product, you can connect with the Tanvi. Tanvi and Sukanya is there. Okay. Thank you so much for your wonderful availability. You're always welcome if you have any concern. Bye, take care.